Hey you guys, welcome back to the channel physicssirjee, and here we are in the solution to the giveaway problem for our anniversary problem contest that I posted a few weeks back, and everyone in the DMs of my app and also in the community posts and also the YouTube video for which I have done this, they have been continuously asking for the solution of this particular video, and there were somewhere around 190 to 200 entries for this particular problem. I was expecting very close to 100, but I was very surprised to receive so many solutions, of which higher number of solutions were right. I was expecting at least only 5 to 10 solutions to be correct, but I was pleasantly surprised that there were nearly 30 odd solutions that were correct. So let me go ahead and first of all give you the solution, and also see how many of you have done it properly. I may not be able to reveal the names of all the students because some students wanted to be anonymous. Okay, so in case you want me to reveal the names of the students who have done it, and in case you are that student who got it correct, once the solution is done you will know whether you have done it correctly or not. You can leave it in the comments section below. Okay, so for those who are new to the channel and watching this video for the first time, this was the video I was referring to. There was a problem that I have released few weeks back, and I asked for a solution, asked the students to send the solution in our app, and this was the question. There is a uniform rod with Young's modulus y, and there are two forces, one compressive and one tensile, that are applied at the ends as shown. And once the elastic equilibrium of the system is reached, as it is keeping on moving, once it has stopped expanding or compressing, our job was to calculate the location of the center of mass with respect to the geometric center in the final state. This was the broad question. So in case you are new, you want to attempt this question, I would request you to pause the video here, read the problem statement, give it an attempt, and then go ahead with the solution that I'm going to look at. So let me be very honest. Okay, so I was the only person looking at all the solutions. Even yesterday or day before, I have released a community post that I was struggling to go through all the solutions because initially for the first 5 to 10 days there were less entries. So I was able to catch up with the reading of those solutions because I was supposed to do the lectures of our courses also, and I was resigned to the fact that no more entries will come. But once the date of closure of the contest came, I started receiving not only right solutions, very detailed proper ones, and I had to keep on reading them. I couldn't finish all of them. Even now as I'm standing, I think there are 40 to 45 solutions that I have not yet read. Let me be very honest, but I had to release the solution. So after the solution is done, in case you have written the correct solution, it will be there anyway in the DM. You just prompt me that you have done your solution right, you will be eligible for the reward. Okay, right. So I have assumed that you have attempted the question either before or now, and I'm going ahead with the first. Let me reveal to you the common mistakes students have done among the solutions that I have received. Right, the common mistakes that students have done. Right. This is one very important thing that whenever I put it at the end of the video, students tend to forget it. So I would request you to stay subscribed to the channel, like the video so that the reach for the channel increases, and also my advice to the serious students who are part of the channel to hit the bell icon so that you need not stay in the YouTube for long time, but whenever a good video of mine comes along, you will be able to get notification for that. So please make sure you do these things for the sake of improvement in the channel's reach. Okay, so as I promised, the common mistake one, I would say lots of solutions that I have received were of the opinion that there won't be any shift in the center of mass. Okay, so second thing that I have checked is assuming uniform density to be taken after the expansion and compression are there, people have given me the solution. These are the two common mistakes that I have seen in the solution. So let's check the PDF file of one of the common mistake solutions. So this was one of the solutions that I have received, where most of things were right, but some of the assumptions I would like to show. I'm not referring to only this file. I've taken a file which looks good on board to explain the common mistakes, and then I'll also take one of the correct solutions to explain how the things should have been done. Okay, right. When two forces are applied, you already know that the acceleration of the rod is 2F by m, very straightforward. And at a distance x from this end, if you try to calculate the value of the tension T, okay, so this part is x and this is L minus x, you can write the expression for the stress versus strain, Hooke's law, Young's modulus relation, and you would be able to get that the value of this strain, which is dy by dx, or y, which is the value of that elongation, would be in this manner. Okay, so you could see that the value of y, which is elongation of the rod till its length of x, was correctly calculated by this particular student in this manner. So which means it tells you that to the left of L by 2 the forces are compressive in nature, and to the right of L by 2 the forces are expansive in nature. Okay, which tells you that if overall length of the final rod is calculated, it remains as L. Okay, so a lot of people thought, okay, fine, left half is expanding, left half is compressing, I should say, and right half is expanding, then the total length of the rod is not changing, so center of mass remains at the midpoint, that is, there is no shift. That is the mistake, because if left half is compressing and the right half is expanding, then left half becomes more dense because it has got compressed as compared to the right half. There should be a shift in the center of mass. This is some point that has been missed by the students. Okay, second thing, some students got this correct up till this point and they thought that there will be a shift. The second common mistake was, like I said in the previous slide, they assumed that the left half which got compressed and the right half which got expanded, they are having uniform densities. Remember, original rod was uniformly dense, but once you push from this side and pull from this side, the compression and expansion will ensure that there will be non-uniform density. So you cannot assume the left half's center of mass is at its midpoint and right half's center of mass is at its midpoint. That is where a lot of students committed mistake. Okay, so like this particular diagram, beautifully drawn by one of our students. So this left half, whatever has got compressed to this green color, and this right half which got expanded is the blue color. Total length remains same, but this left half's center of mass cannot be assumed to be this midpoint. This right half's center of mass cannot be assumed to be this point. Those students who took this, they found, I don't remember the wrong answer, but they found that shift is towards left by FL by 8AY. That was also a wrong answer. It was a correct idea that center of mass shifts to the left, but the calculation wise, it is a mistake. Okay, right. Different parts of the rod expand and compress by different amounts, so that the density itself is a variable as a function of x, and that is where you are supposed to express an integral and try to get the real location of the shift of the center of mass. Okay, right. Right, so this was an incomplete solution where the answer was not written, but I appreciate the effort that has been put up. So let us take one more file in which a student has sent me a proper solution. There are many good solutions, handwritten, typed, colored, everything was there. I was so happy to go through them. I chose only one of those things which I can present on the board. Doesn't mean I'm being partial to that student, and I am not playing down the efforts of the other student. For me, any beautifully written solution with proper physics has won my heart. Okay, right. So to keep the presentation simple, I have taken the solution of Saksham Hajpal, I think that was the name, and this solution also represents the correct solution of many others who have sent it, and as you are watching, you know whether you have sent the correct solution or not. Okay, so the simple setup, like I said even in the previous PDF, is to take a length x from the left end. This is the length x, and draw the FBD of that, and assume that leftmost force F is as it is written, whereas the part where you cut it, you assume that the tensile force T is acting. You will take, if T is to the left, a negative value, that means T is compressive, and if T is to the right, then it is going to be an expansive or a tensile force. T is supposed to be positive, which means it is very simple. Where x is equal to exactly L by 2 in the middle, tension becomes 0, like in the previous slide that I have shown. And if x is greater than L by 2, the tension would be trying to expand the rod, and if x is less than L by 2, tension will try to compress the rod. This is what we have already found out, and same thing can be done using the mathematics here. Okay, so we calculate the stress by taking a part FBD here. For this part FBD, the acceleration is still the same. Remember, we are solving this problem after all expansions and compressions have stopped. Okay, and the body is moving towards left or right in this case by 2F divided by m acceleration. Remember, total force is 2F, mass is m, 2F by m is the acceleration. So this part of the rod also should have the same acceleration. So T plus F should be equal to mass into acceleration. Okay, so that's what we have written here. Okay, right. And mass is given by the proportionality that we can always look for. Right, so this should be mass into acceleration. So this should be mx divided by, let me write that. So this is acceleration, and mass of this particular part should be mx by L. That m gets cancelled actually. Right, so the value of T you could have written. So the value of T is equal to, you get that F that side, so T will be equal to, m gets cancelled here, F of 2x divided by L minus 1. Very clear? That's what I was trying to tell. When x is equal to L by 2, this becomes 0. I was trying to explain the same thing. So once the tension has been found out, with positive sign representing the tensile force and the negative sign representing the compressive force, you can write the stress versus strain relation. If dE is the elongation in dx, dE divided by dx is strain, should be equal to 1 by Young's modulus of the stress, which is T divided by A. This is what we have written. Stress divided by strain is Young's modulus, so strain is equal to 1 by y times of the stress. So this is what this is. I am changing the symbol from what the student has used. I prefer to use dE. Okay, so what I mean here is, on that rod of length x, the dx element, which I am showing as an expanded version here, itself will have an elongation of dE. So dE is the expansion in dx. If dE is negative, it's a compression. That's what we are assuming. So each of these dx elements will have its own elongations, pushing this element towards right, or they can have compressions pushing the elements to the left. So sum of all those d's up till this position x will decide the displacement in this dx element. So each of these elements, what we are having here, they will have some expansions. Sum of all the expansions of these will push this dx element forward or backward. That's the whole point here. Okay, so how do you sum them up? You integrate the d's from 0 to x and add the position of already x. Remember, the expansions will push them, but if you want the location of that with respect to this, the value is x plus the sum of all expansions. So the value of z location, so let's call that this is now pushed to this position because of all expansions. The value of the z is given by this number. This is your z. This is your z. Okay. So z value is the x plus the sum of all expansions that are occurring in this part. So that's what we are rating, and put the value of tension from the previous slide into this and integrate, you will end up getting this. You'll get a parabolic expression which we saw in the previous PDF file also. Right. And one very important thing, if you were asked what is the density of the rod as a function of x, that also you can find out. Please understand, originally when each dx element was uniformly dense, the mass of that element was dm equal to lambda times dx. Assume the old lambda is this yellow one and the new lambda is some lambda prime. You should realize mass is conserved. So the old lambda of dx length and the new lambda prime, this let's say has expanded to a new value, this entire thing will have a new density, but its length also will change, so that the product of lambda prime and dx plus de and the product of old lambda and dx both mean the mass. So when you are using the position of center of mass formula for this, which we'll do in the next slide, you can either use dm with this or dm with this. People or us will actually prefer this because that's an easier function to integrate. Remember, in our integration we'll have a dx, therefore I'll use this rather than d. Even d is writable in terms of dx. Why I've written this is, maybe there is a future question in which lambda prime as a function of x can be asked. Okay, right? So for that you need to take into account. This itself tells you, because each d is different, lambda prime is not going to be a uniform value with x. Lambda is uniform. Originally it was uniform, but after the expansions and compressions, lambda prime won't stay uniform. That's why those students who took the midpoint of left part as the CM, they went wrong there. Okay, I wanted to highlight this part because you might be curious what was your mistake. Okay, so that's it. What is your location of center of mass? ZCM would be equal to integration of ZDM divided by integration dm. Integration dm itself is the mass, and the value of z is x plus that expression in the previous slide. That entire thing we integrate from 0 to L, and you end up getting that the value of that xcm or zcm, this you can write as zcm. Z is also along x, just the symbol that I am using to differentiate. Okay, so will come out to be, upon integration, L by 2 minus this number. Okay, right. So what does L by 2 minus that number means? From this end it was at L by 2 minus. So as expected, because the left side is denser than right side but have same mass, the center of mass is expected to lie on the denser side, which is the left side, and this distance is what our answer was, which is this number, FL by 6AY. That is your answer, FL by 6AY. The total length is obviously conserved, because when you calculate the integration of all expansions and compressions and algebraically sum them up, you end up getting a 0. Total length won't change, but the density will change, causing the center of mass to shift. And that student was so nice to write further comments, which I would request you to pause the video here. I'll just get aside. Okay, read those extra comments that he has put up. Very nice. And in his symbols, this is your D's, and this lambda effective is my lambda prime that I have taken, right? And I would like you to leave a comment below of the experience of solving the problem, also where you got it correct. If your solution was slightly different from what I presented, I've read many and there were some other solutions also which I liked, but I wanted to present a one which is wholesome, so that's why I took this. Did you get it right or did you get it wrong? Where your thought process went wrong? If at all you saw the question, you thought the answer is something and you did not attempt because you thought it was easy, I think you were wrong. It was tricky question. So please leave that comment, and it would be good for a review on how your preparation should be, how you should be looking at problem solving. So that would also give me a feedback on whether to take up more such problems in the future or not. Okay, so do you want more such contests? Because initially the idea of giving the problem solving contest was to celebrate my 1 year in the app and courses and all, but as I started receiving so many solutions, I thought we should be doing more of these things. Throw challenge at a student and receive that, right? So if you want, then I'll do it, but just let me know. Also, there's some let's try to do it in parts for 2025 aspirants separately, the contest, and 2024. This was for everyone. That's why I chose something very close to mechanics. So let me know, leave a comment. And for those who are new, just make sure that you go to the Android or Windows new apps to check the content. The content will be on this app. Also, you have to download the old app, which is called SirjEE Doubts platform now. Both these Android apps, you will find it in the Google Play Store. Make sure you use the Doubts platform app to ask doubts, and use the PhysicsSirjee app to view the content if you are purchasing the course. So those who have got the solution right, what they should be doing after downloading these two apps. So I told what to do. So in the previous video, it was very, very clear. You're supposed to send the photos of both the apps in the Doubts app. And what was the solution contain? It should contain that FL by 6AY. So this was supposedly what should be there. And you not just this answer, but the details of the solution should also be correct. Then only the contest winner will be considered. If you only write the answer, you're not eligible for the reward. And if you wrote the answer correct, but your solution was not proper, then also it won't be eligible for the reward. So if everything was right, just prompt me in the DM that you have got the correct answer. You might have already sent it, no? Just bump that again so that I can send the reward. And what is the reward? You need to just mention the name or the link of the free course from the new app. You just take the link of the course and put it in my DM in this app, SirjEE Doubts platform. From the new app, take the link and put it in this old app, which is the Doubts platform. It will make my life easy so that I can just send you a coupon to ensure that whatever is the price of that chapter wise course, the entire price gets slashed and you'll just purchase the course. Okay, right? So all the chapter wise courses, whether they are from detailed sections or the crash course section, are eligible for you to purchase, right? And whenever you want to convert from chapter wise to detailed full courses, these chapter wise purchases will be refunded, and this contest part also will be considered. So I'll consider that you have paid for that course, even though you are getting it for free. That's it. This is the 2025 batch 1 and batch 2 for detailed course. I already explained. I'll leave a video of that new app and course launches somewhere in the I button above. Just click and check it out in case you have missed it. These are the two batches that are running, right? The difference also I explained, content is the same. And for the 2024 batch 1 and batch 2, double track teaching and single track teaching, both are running successfully right now. That's it. How refunds are to be done, I've already explained. Just make sure you download both the apps. That's it. Thanks for staying this long. Keep supporting the channel, and don't forget to put that like button. Okay, and make sure you subscribe to the channel and try to share the content with your peers, whether you're a student or a teacher. So please try to do that so that the content on the channel keeps coming up. Okay, all the very best, and see you in the next awesome video.